Hi guys, second take of the video. My mouth got a little nasty for the PG-13s out there in the last one. Basically what we're doing right now is Kirchhoff's current law. And what that says is that any currents that either enter or leave a node, and I will explain what a node is in a minute, must sum up to 0. And that'll all make sense in a second, and I'm gonna highlight this puppy in red. This was a big box here. Okay, so that's what that voltage law says. I don't think that's thick enough. I need a really thick red, so you can... Oh, what the hell. Things are sucking right now. What in the heck? I was really confused. Like, what is that? What is that thing that's drawing right now? It's not what I'm drawing. Not what I'm drawing at all. Everything's moving... Okay, so everything officially shifted this direction. I don't know why. It was drawing things really weird, but I'm not even going to worry about it. Alright, so what this says is... Alright, we have circuit elements here. Let me keep that in the picture. We have circuit elements, like resistors. That's a shitty resistor. Okay. I'll probably just use resistors from now on. Alright, and if two or more of those elements are connected together, we put a little dot there, and that's called a node. Now I'm going to label this node A. And what Kirchhoff's current law is saying, it's saying that if we have the rest of the circuit here... Oh, okay, sorry about that, I got a call. So you have the rest of your circuit here, and it comes to some source. It's kind of a crappy drawing. Right here's a node. This whole bottom end is a node because it connects the end of this resistor to the end of that resistor, and it also connects the end of this resistor to the end of that resistor, which also happens to be ground because it's the negative side. Now we're just going to look at our currents. This is what Kirchhoff's law says. We have some current with a value of X, okay? And it's coming, but what happens when it reaches this point? When the current is in the line and it's at the node point. You only have a certain amount of X. And some of it has to go this way, and some of it has to go down. That might be a rainbow that you're looking at, but I think you get it. So some of it has to go left, some of it has to go down, but the two added together can't be greater than X. And that's pretty much what Kirchhoff says. He says that anything entering and exiting sum together must equal 0. So if this is current Y, and this is current Z, and this is current X, Kirchhoff says that negative X, because it's coming in, plus Z, because it's going out, plus Y, because it's going out, has to equal 0. Which is really, I think it's easier to think about if you say X is equal to Z plus Y. That's the same equation, the same exact thing. It's still Kirchhoff, just written with the X on the other side. And you can see that X, this big current, has to equal to the two smaller currents added together. Now the thing is, same thing at the other node, when these two currents come together, you have a small current, you have another small current. They come together and they add up and they equal X again. Because Z is the same all the way through here, Y is the same all the way through there, Z plus Y is going to give you an X. And when you're dealing with nodes, that's going to make this node equation redundant because they're both the exact same thing. If you notice, the equation for the bottom node is still X equals Z plus Y. And you'll always get one redundant circuit node equation. You can have 4 nodes, you'll only be able to use 3 of them because one of them will be redundant and they're just going to repeat. It might not even be the same as any of the other 3 nodes, but it's just repeating information that the other 3 nodes can convey themselves. So, but that's what Kirchhoff says. That's what his current law is. And because this video is already at about 6 minutes, I'm going to cut it off here and I'm going to make another video with an example. All these notes are still going to be here and everything. If this is chicken scratch right here, let me know. I'm going to blow it up for everyone. I'm going to move it down out of the way somewhere. I'm going to scroll down for people to see it. So, here's that circuit. I guess it kind of got messed up when I was moving it. That or just, these are connected. Yeah, it doesn't really matter, to be honest, but that's that circuit blowing up, and I'll start with the example next. And if you feel like you're really confused on this, you might want to read up on it a little. I'm going to be putting a Google book, or if I can't find a good Google book, I'm going to be putting a download link to some sort of book. That way I can reference to something. If any of you have questions, you can go on there and you can be like, oh, you know, look at this problem, whatever. So I'll just catch you in the next video.